Welcome to my 50-second tutoring session in A-level chemistry. In this video, I will explain how the group elements differ from period elements. Kindly subscribe my channel, share, like, comment, and watch the full video. Here's a simplified and condensed version of the periodic table. In the periodic table, the elements are organized in rows called periods based on the number of shells, like period 1, period 2, period 3, period 4, period 5, and so on. Elements in the periodic table are also organized in columns called groups based on the number of valence electrons. Now here are some of the highlighting features of elements in each group. Now talking about the shells and valence electrons. Now elements in each group have the same number of valence electrons but an increasing number of shells. I'd like to explain this with respect to the group 7 elements, that is halogens, that have 7 valence electrons in their outermost valence shell. As you go down the group 7, the size of the halogen atoms increases due to the increase in the number of shells. So as you go down the group 7, the number of shells increase from fluorine to iodine. But the number of outermost valence electrons remains one and the same. That is, the elements of group 7, that is halogens, they have only 7 valence electrons in their outermost valence shell. So elements in each group, they have the same number of valence electrons but an increasing number of shells. Now what about the chemical properties? Elements in each group have similar chemical properties, or they have similar chemical behavior because they have the same number of valence electrons. Now once again, with respect to the group 7 elements, as halogens, they have the same chemical properties because they have only 7 valence electrons in their outermost shell. They have the same number of valence electrons. And they act as oxidizing agents. So halogens belonging to group 7 act as oxidizing agents because they have the ability to accept an electron to complete the octet or the outermost valence shell. In case of group 1 elements like lithium, sodium, and potassium, they have only 1 valence electron in their outermost shell and they behave in similar chemical fashion. That is, they have similar chemical properties. So group 1 elements act as reducing agents because of their lone valence electron, or the only one valence electron that is present in the outermost valence shell. So because of their ability to donate the electrons, they act as reducing agents. So elements in each group have similar chemical properties with the same number of valence electrons. So halogens belonging to group 7 act as oxidizing agents, while metals belonging to group 1 elements act as reducing agents. Now talking about the reactivity of elements in each group. Now the reactivity of the element in each group depends on how easily the atom can gain or lose electrons. Now in case of group 7 elements, that is halogens, they have the ability to accept an additional electron in order to complete the octet. So the halogen atoms, they are short of 1 electron to complete their octet. They accept the electron, act as an oxidizing agent in the process, and thereby attain the stable electronic configuration. While group 1 elements like lithium, sodium, and potassium, they tend to lose electrons to halogens to form salts. They lose electrons in order to attain the stable electronic configuration of the nearest noble gas in the periodic table. Now coming to the elements in each period, here are the highlighting features of elements in each period. Now elements in each period have the same number of shells but increasing number of valence electrons. Let's try and understand this with respect to period 2 elements like carbon, nitrogen, oxygen and fluorine. As you can see, carbon, nitrogen, oxygen and fluorine that belong to period 2, they have the same number of shells. But if you observe the outermost shell, you can see that the number of valence electrons increases as you move from left to right in the periodic table. Carbon has 4 valence electrons, nitrogen has 5 valence electrons, oxygen has 6 valence electrons, while fluorine has 7 valence electrons. So as you move from left to right in the periodic table, the number of valence electrons increases. So we are specifically talking about period 2 elements. And what about the reactivity? Now the reactivity of element in each period depends on the number of positively charged protons present in the nucleus. So carbon has 6 protons in the nucleus, nitrogen has 7 protons, oxygen has 8 protons, while fluorine has 9 protons. So as the number of nuclear protons increases as you move from left to right in the periodic table, the electrostatic force of attraction between the increasing number of nuclear protons that are positively charged and the outermost negatively charged valence electron increases. And this leads to the shrinking of the atomic size. So due to the electrostatic force of attraction between the positively charged nuclear protons and the negatively charged outermost valence electrons, the size of the atom kind of shrinks. And here you can see the atomic size of fluorine is less than carbon. So the reactivity of element in each period depends on the nuclear charge, that is number of the positively charged nuclear protons. So let me explain with respect to group 1 and period 2 elements. Now going down a group, the number of shells increase. Now we are talking about the group 1 elements. With the increase in the number of shells, the number of electrons increase. And with the increase in number of electrons, shielding increases. What is shielding? Now during shielding, the inner core electrons highlighted in red, they partially reduce or block the electrostatic force of attraction between the positively charged nuclear protons and the outermost negatively charged valence electron. So going down the group, the shielding increases. And what about Z effective? That is effective nuclear charge. Effective nuclear charge is the electrostatic force of attraction between the positively charged nuclear protons and the outermost valence electron. Even the Z effective also decreases. So inner core electrons are highlighted in red. Valence electrons present in the outermost shell are highlighted in green, while the Z effective or the effective nuclear charge is highlighted a double-headed arrow mentioned in green. Now going down the group, the atomic radius increases. The distance between the nucleus and the outermost valence electron. The ionization energy decreases. What is ionization energy? The amount of energy required to remove an electron from an atom or ion in the gaseous state. So as you go down the group, the energy decreases because the positively charged nuclear protons lose control over the outermost valence electron due to the decrease in the electrostatic force of attraction. So as you go down the group, increase in shielding wins over increasing nuclear charge. Though there is increase in the nuclear charge as you go down the group, that is group 1, you find that the shielding dominates over the increasing nuclear charge. And the effective nuclear charge, which is the electrostatic force of attraction between the nuclear protons and the outermost valence electrons, also decreases due to the increase in distance. Metallic and ionic nature increases. So metallic nature is ability to donate electron. So the metals belong to group 1. They have the tendency to lose an electron in order to attain the stable electronic configuration. And thereby, they also behave as ions after the reaction. For example, potassium reacts with fluoride to form potassium chloride. Potassium ion as a positive charge, while the fluoride ion as a negative charge. So due to the above contributing factors, electronegativity of the atom decreases. Reactivity increases. So potassium is more reactive than lithium because the ability to donate electron by potassium is much more than lithium. So therefore the reactivity also increases going down the group. So ionic nature increases and basic natures of oxides increase. For example, sodium reacts with oxygen to form sodium oxide, and also it reacts with water. Sodium reacts with water to form basic sodium hydroxide. Now, as you go across a period, the shells remains the same. We are talking about period 2 elements. In case of period 2 elements, the number of shells remains the same, that is 2. Only 2 shells, all the period 2 elements. And therefore the shielding is constant. Why shielding is constant? Because the number of inner core electrons remains the same, that is 2. So as you move from left to right in the periodic table with respect to period 2 elements, you can see the number of inner core electrons remains the same while the number of valence electrons increases. So increase in valence electron does not contribute towards shielding. And atomic radius, it decreases because the electrostatic force of attraction between the positively charged protons and the outermost valence electron increases, and as a result it pulls or draws the negatively charged electrons closer to itself, and in the process the atomic size shrinks or the size of the atom reduces, and ionization energy decreases. So ionization energy is the amount of energy required to remove an electron from an atom or ion in the gaseous state. So because of the strong electrostatic force of attraction between the positively charged nuclear protons and the negatively charged valence electrons, more energy has to be supplied in order to remove an electron from the outermost shell. So there is an increasing nuclear charge winning over the shielding. So as you move from beryllium to fluorine in the period 2 elements of the periodic table, you can see the nuclear charge increases. Beryllium with 4 protons, boron with 5, carbon with 6, nitrogen with 7, oxygen with 8, and fluorine with 9 nuclear protons. As a result, increasing nuclear charge or nuclear protons wins over shielding. So shielding is constant as you move from left to right. Effective nuclear charge increases. That is the electrostatic force of attraction between the nuclear protons and the outermost valence electron, because there is only one shell separating the nuclear protons and the outermost valence electron. Therefore, the electrostatic force of attraction increases. Therefore, the effective nuclear charge also increases. Metallic nature decreases and covalency increases. What do you mean by this? So as you move from left to right in the period 2, what happens? The ability to donate electron by the atom decreases. So lithium, if you compare lithium and carbon, lithium has the ability to donate the electron, while carbon, it doesn't donate. It tries to form bonds with other atoms like nitrogen, oxygen, and fluorine by mutual sharing of electrons, that is by covalency. So covalency is formation of covalent bond by mutual sharing of electrons between the atoms involved in bond formation. And metallic nature, ability to donate electrons decreases. And taking into above mentioned factors, they together contribute towards increased electronegativity. So covalency increases as you move from left to right in the periodic table, and acidic nature of oxides also increase. Like for example, carbon reacts with oxygen to form neutral oxide like carbon monoxide, and acidic oxides like carbon dioxide. So carbon dioxide reacts with water to form carbonic acid, which is acidic in nature. Thank you so much for watching my video. I hope you enjoyed it, and I'll meet you in my next interesting tutoring session.